Ever told your friend, my house is so far from school, and they said, no way, mine is way farther? Who's right? You don't know, because far isn't a number, it's just a feeling. So how do we actually prove whose house is farther? That's exactly what we're going to solve today, the idea of length. Length is simply the distance between 2 points. It could be the edge of your notebook. It could be the distance from your home to school. It's everywhere. You just never called it length before. But here's the problem. If I measure my table using my handspan and you measure it using your handspan, we'll get two different numbers because your hand and my hand aren't the same size. So scientists all over the world sat down and said, this is chaos. We need one common system that everyone agrees on. That system is called SI units, which just means the International System of Units. Think of it like a universal language for measuring, so a scientist in Chennai and a scientist in Canada mean the exact same thing when they say 1 meter. For length, that universal unit is the meter, m. Now here's where it gets fun. Not everything is meter-sized. You wouldn't measure a football ground's height in the same unit you'd use for an ant. So we break it down. For tiny things, like the thickness of a wire, we use millimeter, mem. For slightly bigger things, like your pencil, we use centimeter, cm. For everyday things, like the height of a door, we use meter, m. For huge distances, like the distance between two cities, we use kilometer, kilometer. Notice the pattern? These aren't random words. Let's break them apart like puzzle pieces. Milli means 1,000th, centi means 100th, kilo means 1,000 times. So a kilometer isn't a totally new idea. It's just saying 1,000 meters, dressed up in a shorter word. Here's the full chain, so you never forget it. 1 kilometer equals 1,000 meters. 1 meter equals 100 centimeters. 1 centimeter equals 10 millimeters. Now here's something almost every student gets wrong at least once. Say you're measuring a pin with a ruler. You'd think just place it anywhere and read the number, right? Wrong. The head of the pin has to exactly touch the 0 mark on the ruler. If you start from 1 instead of 0 by mistake, your entire answer is wrong, even if your eyes tell you it looks right. And here's an even sneakier trap. Parallax error. Imagine 3 people looking at the same ruler reading, one from the left, one from directly above, and one from the right. Believe it or not, all 3 will read different numbers. Only the person looking straight down, directly above the marking, gets the correct reading. Looking from an angle bends what your eye perceives, just like how a straw looks bent when it's dipped in a glass of water. So the golden rule is, eye directly above the mark, object starting exactly at 0. Now you might think, okay, but does 1 millimeter of difference really matter? Here's a real example. If the curve of a lock and key changes even by 1 millimeter, the key simply won't turn. That tiny difference, smaller than your fingernail, is the difference between a door opening or staying locked forever. That's why in science, we don't just measure, we measure accurately. A small mistake in the ruler becomes a big mistake in the result. So next time your friend says, my house is farther, you now know exactly how to settle it. Pick a common unit, measure from 0, keep your eyes straight above the mark, and let the numbers speak. Length isn't just something we learn in a classroom. It's the reason your key fits your lock, your dress fits your body, and rockets land exactly where scientists calculate them to. That's the power of getting your measurements right. I'll see you in the next video, where we zoom into mass and time, the other 2 building blocks of measurement.